Okay, we're going to do a whole bunch of these at once. We're looking for the exponent that we would put on 9. And how do we do it? Well, we're going to subtract the exponents. We're going to say 3/4 minus 1/4, and that equals 2/4, which equals 1/2. So we have as an exponent 1/2, 9 to the 1/2. Now, that's a fine answer for us for now, and I'll box it. But you will learn soon that the 1/2 power, if you raise something to the 1/2 power, what you're actually doing is you're rooting it. You're saying 9 square rooted. The 2 in the denominator of this fraction is saying, what number do you multiply together twice in order to get the base of 9? What do we multiply together twice to get the base of 9? Or what's the square root of 9? The square root of 9 is 3. So the real full answer for 13 would be 3. Okay? And in fact, if you just stop here at 9 to the 1/2, for now, I'll find that acceptable. Okay? It'll be hard to check your answers in the book, though, because it'll say 3. So let's start talking about that idea now. Anything to the 1/2 power is 3. And again, the number 2 in the denominator says root it. Find something that multiplies together that many times to get what the base is. Okay? That's how you're going to do that with fractional exponents. We'll see if we come up with that again. And if we don't, then we'll just leave that for the next lesson. Okay? Now, here we go for number 15. N to the what? Well, remember, when you're dividing, you subtract. Be careful here, though. Okay, let's write this out. We have -1 minus -4. And if you go slowly and you know how to subtract integers, that's the same as saying -1 plus +4. And what is -1 plus 4? It is 3. So then the answer would be n to the 3rd power. Okay? Let's keep going. Remember, when you are dividing, you subtract the values. So let's look here for this x to the 11th y to the 3rd over x to the 11th y. We're going to subtract these for the x values. 11 minus 11. What's 11 minus 11? It is 0. So we get x to the 0. I'm going to write it for a second, although you'll see that in the answer it shouldn't be there. And then what do we get for y? We're going to subtract the values again. We get 3 minus, what is the exponent on y? Well, it's an invisible 1. You should know that. So 3 minus 1 is 2. And we can simplify this x to the 0. X to the 0 equals 1. So essentially what we've got there then is 1y squared. And of course we don't write a 1 in front, we just write y squared. And that's what you get, because essentially this is happening. These are canceling out completely and disappearing. And so you have y cubed divided by y is y squared. Okay? For number 19, you'll see that we actually have coefficients. We have these coefficients here, 10 over 5. And what is 10 divided by 5? Well, 10 divided by 5 is 2. So that's what you're going to get there. Now, let's look at the m's. M to the 6th over m squared. Remember, when you're dividing, you subtract the exponents. So we get m to the 6 minus 2, or 4, m to the 4th. And let's erase those marks. Let's deal with the n's now. N cubed over n to the 7th, we subtract n to the 3 minus 7. 3 minus 7 is negative 4. And of course, we want to simplify this. It says simplify it, and typically simplifying means don't write it with a negative exponent. So we get then the 2m to the fourth stays on top because it does not have negative exponents, but the n to the fourth does have that negative. It's actually n to the negative 4, so it's down on the bottom as n to the positive 4. Moving it to the bottom uses up the exponent, and then we've got our final simplified answer. Okay, let's keep going. Let's look at these, for 21, let's look at the threes here. We can say before we resolve this, let's just say anything to the second power over that same thing to the fifth power. Remember, we subtract the exponents, and we will get then 3 to the 2 minus 5 is 3 to the negative 3. We'll deal with that in a second. Okay. Let's move on to the m's. We've got m to the what? Well, we've got the exponents 5 and 7, so 5 minus 7 is negative 2. And what about the t's? We've got t to the sixth minus t to the negative fifth. And let's just write it down. T to the sixth, or 6, minus negative 5. That's the same as 6 plus 5, or 11. So then we would have t to the 11th power. All right, now let's resolve this. Let's resolve all this. You can see that the 3 to the negative 3 moves to the bottom. We're going to put a fraction bar and put 3 to the positive 3 now on the bottom. The m to the negative 2, there's a negative exponent. That moves down here as m to the second, using up the negative in the process. And the t to the 11th does not have a negative, so that stays on top. And that'll stay on top here, t to the 11th over, and we can resolve this 3 to the third power. That means 3 times 3 times 3. 3 times 3 is 9. 9 times 3 is 27. And we get t to the 11th over 27m squared. Okay? We're doing these in pieces. Just deal with each little piece at a time. So let's box that out and we'll be done with it. Okay, last one. We're going to do the same thing here. We're going to deal with the coefficients first, and we get 12 divided by 4. That's 3. Let's erase those. Deal with the a's next. A to the negative 1 over a to the fifth. Negative 1 minus 5. Negative 1 minus 5 is negative 6. A to the negative 6. Let's deal with the b's. Oops. B to the 6th over b to the negative 1. 6 minus negative 1. Minus a negative 1 is the same as plus 1. So we get b to the 7th. And what about the c's? C to the negative 3 divided by c to the fifth. We've got negative 3 minus 5, or c to the negative 8. And now we're going to simplify this. Okay? That equals, well, if we're going to have a fraction bar, something on the top, something on the bottom, you can see the 3 stays on top. The a to the negative 6 becomes a to the 6th on the bottom. B to the 7th stays on top. And c to the negative 8 comes to the bottom as c to the 8th. And that is it. That is simplified as far as it's going to go. Hope that starts to make sense after all that. I really enjoy these problems because it's actually not that tough when you start to see it in pieces. And the way that you want to see it in pieces, again, is to, for example, deal with the coefficients separately, deal with the m's separately, deal with the n's separately, for example, and simplify all of them in pieces like that. Hope that was helpful.